In this example, we're going to look at integrated rate laws. And specifically, we're going to look at how to graphically determine the order of a reaction, its rate law, and find its rate constant. So in this specific example, we're given some data concerning the decomposition of sodium azide. And then we're asked to determine the rate law, the integrated rate law, and the rate constant. And so here's our time and concentration data. So in order to solve this problem, I'm going to need to make 3 plots. And so I've given you on this slide the equations for the integrated rate laws. And they're all written in the form of y is equal to mx plus b. And so what we're going to do is we're going to make a plot of concentration as the y variable and time as the x variable to test if it's 0th order. Then I'll make a plot of the natural log of the concentration versus time. And I'll make a plot of 1 over the concentration versus time. And only one of these equations, when I make these plots, should give me a graph that is linear. The other ones, the data is not going to have a linear relationship. And so the one that turns out to be linear will tell me the order of the reaction. So let's go to Microsoft Excel. And so I've already entered in some of the data here into Excel. So I've got the time data and the concentration data. And anytime you want to make a plot in Excel of y versus x, you always want the x variable to be in the left-hand column and the y variable to be in the right-hand column. And so with the original data we're given, we'll test if it's 0th order. So I'll just plot the concentration versus time. To test if it's 2nd order, I'll plot 1 over the concentration versus time. Now I don't have to get out a calculator and do all these calculations myself and type in each number. I can get Excel to do that work for me. So I'm going to enter a formula. So to tell Excel I'm going to enter a formula, I'll type equals, and I'll do 1 over, and I'll click on the cell that I want to take the inverse of. And then hit enter. I don't have to retype that formula every time. I can just copy the cell that has the formula, then highlight the cells I want to paste it into, and right-click, paste. And so Excel has done all the work for me. Now I'll do the same thing to test for my 1st order reaction. So I want the natural log of the concentration. So I'll enter another formula. So equals ln for natural log, open parentheses, click on the cell that I want to take the natural log of, close the parentheses, and I'll copy and paste that formula. So right-click, copy. I'll come down to paste it. Now I want to create my 3 plots. So I'll highlight the data I want to graph. And in Excel on a Mac, you probably have these tabs here. And so I'll click on the Chart tab. Click on the Chart tab. And then click on the type of chart that I want to insert. On a PC, you probably have some Insert tabs in the top of your Excel window. So you'll go to Insert Chart. Now whenever we want to plot y versus x data, we don't want the line graph. We want to come down here and do scatter. All right, and so here is the plot of concentration versus time to test if it's 0th order. So I'll right-click on one of my data points, go to Add Trend Line. I'll display the equation on the chart and display the r² value on the chart. So this data looks okay, but you can see the data points don't quite exactly fall on my line of best fit. So this may not be a 0th order reaction. Let's test it for a 2nd order reaction. So I'll highlight the data again, go to Insert, I already have my chart types here, so I'll just come down here to Scatter. So here's my plot for a 2nd order reaction. So again, I'll enter trend line. So right click on one of my data points, add trend line, display the equation, display the r² value. If you don't see these options to display the equation, display the r² value, click on this Options tab over here, or you may have to scroll down if you're on a PC. Do OK. So again, my data doesn't quite exactly fall on the line, so not sure. It's not looking very good for 2nd order. So now I'll test for a 1st order reaction. So highlight my data, insert another chart. That's looking more promising. So I'll go ahead and add a trend line. All right, here my r² value is exactly 1, so that's better than the other 2. You can see the data points fall exactly on the linear trend line that I added. So a plot of the natural log of the concentration versus time gave me a straight line, so I know that it's a first order reaction. So let's go back to Microsoft PowerPoint. All right, so this is the plot that gave me a straight line, so I know that it's a first order reaction. So the question asks us to determine the rate law, the integrated rate law, and the rate constant. So if it's first order, that means the rate law, or sometimes we call this the differential rate law. It tells us how the rate depends on the concentration. So it's rate is equal to the rate constant times the concentration to the first power. If it's first power, you can either write the 1 or usually we just leave it off because it's understood. If it was second order, then I'd put a 2 here and whatnot. We know the integrated rate law, it's first order, so that tells us the natural log of the concentration is equal to minus kT plus the natural log of the initial concentration. Now we want to determine the rate constant. So for a first order reaction, a plot of the natural log of the concentration versus time gave us a straight line. And so whatever constant is in front of the x variable, that is the slope. So the slope is equal to negative k, or k is equal to the negative of the slope. So the slope is negative 0.056, then the rate constant is positive 0.056. And then the only other thing we need to worry about is what the units on the slope are. So for any line, if I wanted to determine the units on the slope, it's just the units on the y divided by the units on the x variable. And so in our case, when I take the natural log of the concentration, it doesn't have any units. The natural log essentially wipes out the units. So no units on the y. The units on the x-axis are seconds. Seconds will go in the denominator, so it'll be 1 over seconds, or seconds to the minus 1.